So we're going to start section 1.4, which is about indexed collections of sets. So recall from our previous section, we previously looked at Venn diagrams. For three sets, A, B, and C. So I'll draw the Venn diagram here. We had three circles, one for the set A, one for the set B, and one for the set C. And then we can talk about operations on these sets. So for example, A union B union C. And if I looked at the Venn diagram for that, it would shade in anything in the A circle, the B circle, or the C circle. So if I wrote it as a set, it would be all the elements where X is in A, or X is in B, or X is in C. So to be in the union, it just has to be in one of those three sets. But sometimes we want to take the union of several sets. Consider the union of several sets. So for example, I have the set A1, A2, all the way up to AN, where n is at least 2. And then I want to take the union of these sets. So the union of these sets is denoted by A1 union A2 union ... up to AN. Or another way you can denote this instead is just with a single union symbol. I equals 1 to n of AI. And this set is defined as the set of all elements, so X, where X just needs to be in one of these sets. So it needs to be in AI for some I, where I is between 1 and n. So in order to belong to this union, elements must belong to one of these sets. One of these sets. So either A1 or A2 or A3 and so on. So let's look at an example with unions here. Let's look at, let's say B1 is going to be the set 1, 2. B2 is going to be the set 2, 3. B3 will be the set 3, 4. And you're going to keep going until you get to B10, which will be the set 10 and 11. So there's this general pattern to these sets. So in general, BI would be the set containing I and I plus 1. And we're restricting I to be 1 up through 10. What I want us to do is determine the following. So let's look at the union from I equals 1 to 5 of BI. So what this means is I'm taking the union of B1, B2, B3, B4, and B5. So I'm taking the union of the set 1, 2, 2, 3, 3, 4, 4, 5, and 5, 6. So you're taking the union of all these sets together. So you're going to take any element that was in any of these sets. So 1 was in 1, 2, 3, 4, 5, and 6. Let's look at another one. B, the union from I equals 1 to 10. Take a minute and maybe pause this video if you want and fill in what you think this is equal to. It's going to be the set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. You're taking the union of all of those previous sets. You're going to get the numbers 1 up through 10, up through 11. You could also write this as the set 1, 2, ... all the way up till 11. So either one of those is fine. All right, what if I ask you for the union of from I equals 3 to 7 BI? So what are we taking the union of? B3, B4, B5, B6, and B7. So B3 will have the numbers 3 and 4 in it. B4 will have 4 and 5, 5 and 6, 6 and 7, 7 and 8. So for this next one, what I want us to do is look at the index I equals j to k of BI. So what I want us to do is essentially generalize the previous part. So let's think about it. Our first one we start off with is j. So it'll be j and j plus 1. The next one, j plus 1 and j plus 2. And then you keep going till you get to your final set. Look at your upper index here, k. So this stops at the last set, k and k plus 1. And what do I get when I take this union? It'll be j plus 1, all the way up through k plus 1.